Myself, Gaurav Bhagwan, Assistant Professor of History Department of FJ Digital Engineering and Technology. In last session, we have finished with number 4, that is radio wave propagation. Right? In today's session, we will start with number 5, that is polarization. In this session, we will cover internal polarization, cross-polarization discrimination, ionospheric depolarization, rain depolarization, and ice depolarization. Now, first we are focusing on antenna polarization. Now, first of all, what do we mean by polarization? Polarization is a way to give a transmission signal a specific direction, or we can say that it makes the beam more concentrated. Like my wave is linearly polarized, or the wave is circularly polarized, right? So the polarization of transmitting antenna is defined by the polarization of wave it transmits. If we consider a horizontal dipole, which will produce horizontally polarized wave, then two dipoles mounted or close together symmetrically and at the right angles to each other will produce a circularly polarized wave. If it is fed with the currents equal in amplitude and with the difference in the phase shift of 90 degrees. So, the polarization of receiving antenna is to be aligned with a wave of transmitted antenna. Why? Because for a maximum power transfer, right? Now, the next and the most important topic is cross-polarization discrimination. First of all, the propagation path between a satellite and Earth station passes through ionosphere, and we can say that different layers of ice crystals in upper atmosphere and rain, and all of which are capable of altering the polarization of the wave being transmitted. So, the orthogonal component may be generated from the transmitted polarization. So, that effect is referred to as a depolarization. Alright? Which will cause the interference where orthogonal polarization is used to provide isolation between a signal, either in case of frequency reuse. So we can say that a depolarization is an effect where a satellite link's wave polarization is altered, either because of ice, either because of rain, or because of ionosphere. Right? So the polarization is altered after it being launched by antenna. Then how it can be a change? So two measures are being used to quantify the effect of polarization interference. Most widely used is cross-polarization discrimination, that is XPD. Over here, the electric field component E1 is transmitting side, and after traveling through a depolarizing medium, two components are generated. One is copolar, another one is cross-polar. We can say that my transmitted signal is having a vertical polarized signal, and my received signal having a two component. One is having a same polarization as of transmitted signal, and second component that is present is cross-polar component. Right? So how to determine this cross-polar component? It is represented with the help of XPD, that is cross-polarization discrimination, is equal to 20 log E11 upon E12. This is E11 upon E12. Right? If I am going to transmit a vertical polarized wave and horizontal polarized wave at the same time, then after passing it through depolarizing medium, then my transmitted signal and received signal will be E11 and E21 and second signal, that is E12 and E22, right? So this E11 is a copolar component for E1 and E21 is the cross-polar component for E2, right? And over here, E12 is copolar for E2 and E22 is cross-polar for the two orthogonally polarized signals with magnitude E1 and E2 are transmitted. So after transversing the depolarizing medium, copolar and cross-polar components exist for both waves. If you want to isolate the copolar and cross-polar component, then polarization isolation is required. So it is defined as the ratio of received copolar power to the received cross-polar power. As we have seen earlier, E11 and E22 are the copolar component for E1 and E2, right? And E21 is the cross-polar component for E2 and E12 is cross-polar component for E1. So it is defined as I is equal to 20 log E11 upon E21, right? That is the polarization isolation. When the transmitted signal have the same magnitude, E1 is equal to E2, then the receiving system introduces a negligible depolarization. That means there is no alteration of polarization. So this I and XPD both have identical result, both are same. Now ionospheric depolarization. So the depolarization is due to the presence of ionosphere. As we know that ionosphere is the upper region of Earth's atmosphere that has been ionized, mainly by solar radiation. So the free electrons in the ionosphere are not uniformly distributed but form layers. So when a linearly polarized wave transverses the ionosphere, it sets in the motion the free electrons in the ionized layer. So these electrons moves in the Earth's magnetic field, therefore it experiences a force. So the direction of electron motion is no longer parallel to the electric field, which will cause electrons to react back onto the wave. And this net effect is shifting the polarization. Right? This is the way of how ionospheric depolarization occurs. Next is lane depolarization. As we know, the ideal shape of raindrop is spherical, since it minimizes the energy required to hold the raindrop together. So the shape of the small raindrop is close to spherical, but the larger drops are better modeled as oblate spheroid with some flattening underneath as a result of air resistance. So linearly polarized wave can be resolved in two components. One is vertical polarized and other is horizontal polarized. And the vertical component of electric field which lies parallel to the minor axis of waveform. So it encounters less water than the horizontal component. Why? Because a ray onto the earth is actually in direction of vertical, right? So there will be a difference in the attenuation and the phase shift experienced by each of the electric field components. And this difference are termed as a differential attenuation and the differential phase shift. And it may cause the depolarization of the wave. Right? Now, the ice depolarization. The ideal shape of raindrop is spherical and it minimizes the surface tension which is required to hold the raindrop together. So the shape of the small raindrop is close to spherical, but larger drops are pattern model as an oblate spheroid. So depolarization is ice is differential phase shift with a little differential attenuation present. Almost rain depolarization and the ice depolarization have a minor difference. Ice depolarization have a differential phase shift and a differential attenuation because the ice is a fluid dielectric unlike a water, which has a considerably a less dielectric. Right? So what we are talking about 5 is finished. These are the references.
So we can say that polarization is the orientation of wave. That means a wave which is referred to the time varying behavior of electric field strength, which is vectored at some fixed point in space. Okay. There are different types of polarization like linear, elliptical, circular, vertical, horizontal, right? So linear polarization means what? Linear polarization means a time harmonic field which is linearly polarized at a given point in the space. That means if the electric field vector at some point is always oriented along the same straight line at every instant of time. Okay. Now the next one is elliptical polarization. That means a wave which is said to be in elliptical polarization at a various instant of time in which our electric field will going to be changes continuously but with respect to time. And circular polarization means we can say that a wave is said to be a circular polarized if a tip of electric field which traces out to a circular. That means the orientation of wave will be a circular. Okay. And vertical polarization means the orientation of electric field is perpendicular to the surface of the earth. And horizontal polarization means orientation of our electric field will be parallel to the surface of the earth. So if in the exam the question will be asked like what is polarization and what are the types of polarization, then you have to write this different types of polarization, 5 types. Okay, and the most important question from this chapter is cross-polarization discrimination. And you have to draw both the diagram and you have to define what do you mean by XPD, that means cross-polarization discrimination, and what do you mean by cross-polarization isolation, both formula as well as the definition. Okay, so over here chapter will be finished. In the next session we will start a new chapter. Okay, thank you for your attention.
which I had used. Thank you.